Do you know this LED bulb is controlled by single IC and not any microcontroller or any other complex circuit. This bulb works on 230 volt, but it is still controlled by a small driver circuit. Do you also wish, if you are interested to know why this LED bulb flickers or makes buzzing sound, then you are in the right place. Hello all, welcome to our YouTube channel. Today we will be discussing on a very important topic, how to understand the LED driver circuit. So let us understand the basic block diagram of LED driver circuit. Input you have household supply of 230 volt, that is what you are getting from your household AC line. This 230 volt is rectified using a bridge rectifier. Whatever 30 volt AC you are given, it is rectified and it is coming as pulsating DC. Once this pulsating DC is achieved, next is filtering, and it is done by a capacitor. What does this capacitor do is, it will be a very high value capacitance, so that this ripples will be completely removed and it will be almost a constant DC line. That is what it is achieved from a filtering circuit. Next, after this filtering circuit, a DC voltage line is available. This fixed DC voltage line, with the help of driver circuit, you will be driving this LED bulbs. Means with this power supply and with the help of this driver strategy, you will be driving the LED bulbs to achieve the required intensity of LED bulb. So here the most important topic is understanding the driver circuit. So let us deep dive to this topic and understand what does this driver circuit consists of and how does it works. So LED driver circuit has one single IC. It is a 8 pin IC. You can see it has 8 pin dual pin IC, means dual line IC. There are 4 pins at one side and 4 pins at another side. As we discussed earlier, you have AC supply line and then there is a bridge rectifier. So this is the bridge rectifier, and once bridge rectifier gives the output, it is filtered using a filtering capacitor, and then you have your LED driver circuit. So here is the LED and this is the driver circuit. This driver circuit is the IC which we are discussing now, that is BP2831A. So this is the cheapest IC which all the cheap LED bulbs which are available in the market uses this IC, because it does not have any complex control circuit to protect the device, but it is very cheap and very compact circuit design, so that for all your LED bulb with a cheaper application this can be used. So now let us understand how this BP2831A circuit works, or this IC works. So first of all, this BP2831A circuit works on a principle of buck converter. That means the DC voltage which is available for your LED driver circuit will be operated as a buck converter with this IC, and then it is regulated to fixed voltage to drive your LED bulbs. What does that mean? You have input of a fixed DC voltage which is rectified in this area after filtering capacitor. So you have a fixed DC voltage. This fixed DC voltage is converted to another fixed DC voltage with lower voltage range and with controlled current. If this is around 200 volt, so this output will be around 60 to 120 volt DC. That is how this voltage level is converted, and then this IC majorly works on one important phenomena, that is critical conduction mode. What is this critical conduction mode is, so generally buck converter as inductor and switch and capacitor. So because of the property of the inductor, the current conduction may be continuous or discontinuous based on the inductance value. What does that mean? For any buck converter, if the inductance value is too low, then there is a chance of reducing the discharge current in the inductor to completely zero. That means current will charge in the inductor, and after some time, due to operation of switch, it will try to discharge and it might reach to zero. After a certain period of time, it will again rise to highest value and then again reduce to zero. So here, for certain portion of time, the current will be zero. This is called discontinuous conduction. Means this current rising and falling is not continuous. So this is called a discontinuous conduction mode. And there is one more called continuous conduction mode, where current will never fall to zero in the inductor. It will be always rising, falling, rising, falling, rising, falling. So it will never fall to zero. This is called continuous conduction mode. This kind of conduction will happen if there is a high inductance value. Very large inductance value is selected for that buck converter, then you will have this continuous conduction mode. If not, there is a discontinuous conduction mode. But for our application of LED driver circuit, it is operated in critical conduction mode. That means the L value is chosen such a way that it is critically conducted. That means current reaches to maximum value and later it will drop to zero and immediately it will rises to maximum value and immediately drops to zero. This is called critical conduction mode. If this part is clear, with this type of switching, this IC controls the current of the LED bulb. So one important or primary question, how it is controlling the LED bulb? If this is the circuit, how it is controlling the LED bulb? Initially, we have this IC which is getting the DC voltage from rectifier circuit after bridge rectifier and a filtering circuit. With this DC voltage will drive this IC BP2831A into startup phase. In this startup phase, what this IC does is, it will just charge the inductor current and it will try to put the MOSFET in on condition. Means when internally when the I switching MOSFET is turned on, that time there will be no output at the drain pins 5 and 6, which is connected to your LED drive circuit. When this internal MOSFET is turned on, there is no current to the driver circuit, and that time the inductor will charge and also go to the maximum value. The current in the inductor will go to maximum value. Once it is done, the next part is very simple. Once current goes to maximum value, the MOSFET internal to BP2831A turns off, and with this LED bulb is turned on. So this will drive the discharge current from inductor through the LED, and that will cause the LED to turn on. Whatever the discharge current of the inductor is there internal to the IC, that will drive your LED bulb. So that is how LED bulb is turned on. Whenever the MOSFET internal to the IC is turned off, then LED is turned on. That means what does it? We'll just try to recollect. When MOSFET is on, LED is off. When MOSFET is off, then LED is on. That is how the MOSFET is controlling this LED bulb. For this, there is no need to decide the design aspects of the MOSFET. MOSFET, based on its breakdown voltage, it will turn on and turn off. Because of that reason, LED bulb will be also turning on and off. So earlier we discussed this LED bulb has this flickering nature, and there is a buzzing noise in the LED bulbs, some of the LED bulbs. Generally it happens in cheap LED bulbs. The reason is the way it is designed for the application and the inductor which is selected in that LED driver circuit. If inductor value which is chosen is very low, frequency of MOSFET switching will be very low. What does that mean? The on and off tendency of this MOSFET and LED bulb will be very low. So because of that, it can be, if this frequency is very low, then it can be seen in the visible eyes, the on and off of the LED bulb. That is the reason you will see flickering of LED bulb, and this can also cause the buzzing noise. So design wise, if proper inductor value is chosen with high value, then frequency will be high, causing no flickering, right? And one more issue with the cheap LED driver circuit is there is no current controlling aspects of this device. That means there is a chance of going bad of this LED very soon, because there is no control of the output current to the LED. So that's it about the LED driver circuit. In next video, we'll try to do the reverse engineering of one of the LED driver circuit, and then we'll simulate in one of the tool to produce the required desired outputs. If you have liked this video, please do like, share and subscribe. Thanks for watching.